Now we're going to start getting into problems that are a little bit more interesting when things are accelerating. So we're going to start out with a definite definition of acceleration. Acceleration is the rate of change of velocity. Now what does that mean? Rate of change means how quickly the velocity is changing. And every time I find a rate of something, I can divide it by time. So rate, we're going to divide by time. So in this case, the acceleration is going to be the change in velocity divided by the change in time. Now, in physics, any change in velocity is an acceleration. Okay? So there's three ways. The first way, and we think of this when we say the word acceleration. When we say something's accelerating, we mean it's speeding up. Okay? The velocity is going up. Okay? It's changing. That's an acceleration. Now, another way of changing your velocity is to slow down. Okay? In English, we say it's decelerating, okay? But in physics, we're still going to call that an acceleration. And deceleration is just a type of acceleration. And the third way is one that you may not think of. Remember, velocity is a vector. Okay? So I can make it bigger by speeding up. I can make it smaller by slowing down. But I can also change its direction. So any one of these three things, or any combination of them, causes an acceleration. So here's an example. In which of the following examples is the object not accelerating? A ball dropped from rest. As I drop something, gravity is going to cause it to speed up as it falls. Okay, so that's definitely accelerating. All right. A car traveling at a constant speed. Okay, so we're not speeding up, we're not slowing down. In the same direction, so we're not changing direction. Oh, that's none of these three things. So therefore, B is not accelerating. Part C, a car traveling at a constant speed. Oh, that sounds like it's not accelerating, except it's going around in a circle. So it has a change in direction. Okay, by definition, a change in direction causes a change in velocity, because velocity is a vector. Therefore, that's an acceleration. And then the last one, a ball rolling to a stop. We got slowing down. Okay, so that's accelerating as well. So the only one that is not accelerating is if you're going at a constant speed in the same direction. Okay, now, when something's accelerating, we're going to use one of these four equations. Okay, I'm going to look at this one, 2, 3, 4. All right, just so I can refer back to them. They really don't have to go in that particular order. Now, my variables in here, A stands for the amount of acceleration. V0 is the initial or starting speed. V is the instantaneous speed, the speed at any moment. T is time, and delta x is displacement. Now, the acceleration of gravity near the Earth's surface is always going to be the same as long as we ignore air friction. And it's going to be 9.8 meters per second downward. Okay? We can round that to 10 meters per second squared for ease. So remember, it's really 9.8, so if we're doing a lab, we want to be really accurate, we're going to use 9.8. Okay? However, most of the time, we're just going to use 10 to make that a little bit easier. Now, how to solve these problems, okay? And at first, they may seem really, really easy, and you might not feel like you have to make these steps. However, when you get to a trickier one, it's a good idea to do these steps. The first thing is you may want to make a sketch. Sometimes you can skip it, but I find it helps a lot. The second one is to identify your givens. Third thing is to identify your unknown. Okay, that's actually kind of important. What are you looking for? And then the fourth thing is then choose the equation that you want to use. mistake a lot of people make is they read a problem and they immediately think, oh, I think that's going to be equation number 4, and then they try to stuff the variables into that, okay? You may have the wrong equation if you do that. If you do it in the order, you identify the givens and identify unknowns, it's going to be obvious which equation to use. So now, here we have an example. The car is traveling at 20 meters per second. When it puts on its brakes and comes to a stop, covering a distance of 80 meters, what is the acceleration? So, my givens. The car is traveling at 20 meters per second. That's the beginning of the problem. That's the speed. So the speed at the beginning is this initial speed, v0. So I'm going to say over here, v0 equals 20 meters per second. Puts on its brakes, comes to a stop, covering a distance. Oh, here's one, distance of 80 meters. Distance and displacement, we use delta x for that. And then I want the acceleration, that's my unknown. Now, a little hint on these is you're always going to have 3 givens, all right? And I only have 2 so far, all right? There's a third one. It's obvious to find the numbers, and those are givens. But there's another one in here that's a little subtler. It says it comes to a stop. When you come to a stop, your velocity or your speed at that moment, your instantaneous speed, is 0. So that stop tells me that the velocity is 0. Now I have 3 givens and 1 unknown. Now I can choose the equation. The equation I choose has to have those 4 variables, v, v0, delta x, and a. My other variable up here is t, and I don't have that one, so I can't pick an equation that does have t in it. So if I look, okay, number 1 has t in it. Number 2 has t in it. What am I going to do? Oh, number 4, all right, doesn't have time. So I'm going to use that equation. So I'm going to write the equation. Okay, and that's actually an important step on a long answer problem. If you don't write the equation down before you plug in, you can lose some credit. Now I'm going to plug in. v with 0, 0 squared equals v0 is 20. I'm going to square that plus 2. A is my unknown that I'm looking for, and then delta x is 80. Now it just becomes a pretty simple math problem. 0 squared is 0. 20 squared is 400 plus, now, because of the commutative property, I can do the multiplication in any order, so I'm going to do 2 times 80, gives me 160a. Alright, now I would subtract 400 from each side, so minus 400 equals 160a. And then divide by 160, and I end up with a equal negative 2.5 meters per second. And the units for it is meters per second squared. So that's my answer. Now it's got that weird negative in there, okay? It's because it's slowing down. Now negative accelerations don't always mean slowing down. We'll talk about that a little bit at another time. And I'm going to stop there, and in our next video we're going to talk about gravity pulling on objects.